Hi everyone. So I'm going to talk you through the work that we did in Work Package 1 between the Institute for Transport Studies at the University of Leeds, where I'm from, DTI in Sweden, as well as with the help and input, sometimes very large, from all of the partners, for example, Lasta here, Lucien and Tudor, and Elisa, everyone really. Okay, so I have two presentations. Each one I adhere to the guidelines of 10 slides per each, so that's okay. But I didn't on the size of the font, so maybe I'll take some more material there. Right, so the introduction and motivation for our work is basically to look at the economic aspects of all of these wonderful technologies that have been developed as part of NeTIRail. And this was a challenge in a way, because the understanding in economic terms of technology and technological changes is not there fully, and it's something that needs still to develop further. So we start from the assumption that technology can improve efficiency and can take us beyond the possibilities that we currently experience, therefore can take us to situations which we cannot achieve with existing technology. But these technological changes can be costly, and they need investment, sometimes substantial investment. So it is important to have both a financial rationale for the agents actually investing, like infrastructure managers, for example, but it's also important to have a wider economic understanding, because if there are benefits out there beyond what the financial benefits for the agent are, there's an argument there to try to find a way to implement these new technologies. So cost-benefit analysis is a widely used tool in the field of transportation, but it's not so much utilized in the area of assessing technological innovations. One of the objectives of NeTIRail, as David explained very nicely in the morning, was to provide affordable solutions for less utilized lines. So there are certain challenges there, but the most important one was to look to actually be able to assess whether the technology is a solution that is worth going forward, and that actually the alternative is more expensive than applying the technology. The alternative there can be continuing doing things as we are at the moment, but it could also be some other technology that we're still unaware of. But more importantly, we need information for any of this sort of analysis to be meaningful. And as Eric said before, we have to be modest very often with the kind of thing we are able to say or not. But we try our best to at least try to inform and improve the decision-making processes of the railway systems. That's our main target. So in general, the methodology we follow is very simple. We try to put in a balance. First, identify all the costs and all the benefits of every innovation. We can more or less, we have assessed, I think, 9 or 10 innovations. And in general, for this project, we came to the conclusion that most of these are investment costs, which in general have been tried to be relatively low to achieve this aim of affordable solution for less utilized lines. And the main benefits comes in the form of cost savings, which we talk about life cycle cost savings. So in the long term, looking at all sorts of operations in the railway, with renewals, maintenance, and so on. And at the same time, we also expect some user benefits, like what Elisa mentioned before, punctuality, safety, and so on, improvement that the users can benefit from. So our process was basically to identify the case study lines and look at the scenarios, and that was mainly comparing the situation right now with the situation that we will expect to happen with the innovation being implemented. And then the most challenging part was to quantify and value all the costs and benefits. We couldn't do a proper valuation of all of it, especially user benefits, due to data limitations, but we achieved some quantification on the cost element mainly. So I'm gonna walk through, so just a summary table. Basically, the idea is that we also looked not only at the overall cost and benefit, but also who they accrue to. So whether they are for the infrastructure manager, operator, or user benefit, or users. Most of the innovations here are particularly beneficial for infrastructure managers. And I'm going to try to summarize briefly what some of the conclusions from these CBAs on the different innovations. I'll try to do this at the high level without going into too much detail, but hopefully it can give you a feeling of the economic impact of the NeTIRail project as a whole. So starting in the same order that we've been listening to the presentations today, so with the lean techniques innovation, this is basically zero cost innovation. It doesn't have any upfront investment required. It's simply the cost, if any, was already borne by John and his team, identifying the processes and observing how things are done. Once that is done, you can actually have a set of recommendations of how to do things differently, so managerial changes. And that can lead to a lot of savings, which we can summarize as relating to higher productivity of labor and capital. So with the same people and the same materials and capital, you can actually achieve the same output that you are at the moment, but then you can have those resources to do something else as well. As a result, we have some figures there, but they are representative of the case study in Turkey, and they are highly dependent on labor costs. Additional benefits of this innovation will be increased availability of trucks, because you're basically doing the task quicker. You can have the trucks for doing other things longer. Right. Second innovation we looked at was the fastening systems, so choice of different clips. This was done by our partners in Sweden, and they use a more aggregated approach. Whereas in the first approach, we looked at observed data from our partners here. We didn't have that detailed data on what was the cost of the clips and the consequences on renewal costs and maintenance costs exactly. So the approach was an econometric one, where we tried to identify, pick up what is the impact for the Swedish railway, by the way, of having different type of clips, because we had data on all the Swedish network, and part of the network used one clip, part of the network used different type of clips. With the econometric approach, you're more or less able to pinpoint what is the additional marginal cost of one or another clip. Of course, this is also a challenging method, and it puts questions on the reliability of the estimates, but that's the best that we could get here, and it gives an indication of more or less, for the Swedish context, what is the extent to which we will consider worth investing in different type of clips. Moving on to lubrication techniques, there's already some well-known literature out there, as we saw in the presentation this morning. We did some study for Slovenia, where so it's particularly narrowed, and we were looking at the effect of lubrication versus no lubrication, where perhaps you could argue more meaningful way would be to compare different sorts of lubrication, but we didn't really have information for that. As you can see, this sort of is in line with what we saw this morning, so huge benefits of having lubrication, because it helps reducing maintenance costs and renewal costs in a long period of time. And additionally, we will also expect some additional benefits like reduced delays, improved safety, and reduced pollution as well. Finally, Work Package 2, we also look at transition zones. Again, we used an econometric approach, also with the Swedish data. And this one was a very interesting one, because this seems to be a knowledge out there, or a belief that transition zones incur much higher cost. But there's no real quantification anywhere, or at least we couldn't find it, how much more do these transition zones cost compared to other parts of the tracks. And what we found by looking at the Swedish railway, we basically had some specific variables identifying those sections of the track which had transition zones. So we were able to compute what is the additional cost per year in altogether renewal, maintenance, and so on, associated with this part of the track. And it seems to be around the line of 60,000 euros per transition zone over 25 years, which means that this, if we were to implement the heavier sleepers that was discussed this morning by David, we would be looking at trying to make it cheaper than that. So that's the maximum benefit, so cost saving that you could achieve, at least with the Swedish railway. However, this is an area where clearly much more research is needed to actually understand what are the specific drivers that make these transition zones much more expensive. So what are the activities behind it? And that's what the econometric approach cannot tell us. So moving on to work package 3, here, this was the first one we looked at was the trolley wire model for overhead lines. There was very little evidence in there because it's a new model for railway. It has been applied, but not in the railway. Therefore, we try to look at what evidence is there for traditional overhead line systems, so for the catenary wire model. It seems quite expensive in general, and the little evidence we gather seems to point to much lower investment costs for the trolley wire. However, it will have probably higher maintenance costs. It is very unclear to what extent this is true, and probably we'll have to wait until some real-life application of the system is implemented. And additionally, there's an additional cost in this case, that if you were going to electrify one line with the trolley wire model, you will have a much lower speed restriction than the catenary wire model. So you'll have to make that trade-off there. So it's probably more beneficial for lines where you don't really want to go higher than 80 kilometers an hour anyway. And now, moving on to monitoring techniques, we first have here the onboard overhead lines monitoring, still in work package 3. The monitoring technologies, there's one specific question there, which is, what is the value of information? We start from the basis that the main benefit of all these monitoring technologies is the information they provide. But of course, that information needs to be processed and utilized for it to be valuable. Otherwise, there's no value in it, in the innovation itself. And therefore, then, the question is, what are the infrastructure managers going to do, or the operators, with that information? How are they going to process it, and how are they going to use it, for example, to move from current practice to a new practice where they are more preventative and they use more proactive approaches to maintenance and renewals, trying to be more observant of what problems could be with the track and trying to anticipate failures before rather than having to wait and correct them, which normally tends to be more expensive. So what we've done with this, in light of these uncertainties of every infrastructure manager could take this information differently, the approach we've taken is something that the Department for Transport in the UK called, what was it called? I forgot the name now. Can you remember? Anyway, doesn't matter. This is a way of applying CBA, cost-benefit analysis, anyway. So what we've done is estimate what the investment cost of the innovation is, and for the life period of that technology, for instance, if the ABA system is meant to last 10 years, we calculate what's going to be the annual cost related to having that technology, and that puts the boundary there to say, right, if you are expecting to save at least that amount of money in corrective costs and so on, then it's definitely worth going for that. And that's because anything else that is not accounted for is a positive. So all additional benefit will be reduced delays. If you're more proactive, basically you're able to have more control over your track. You can then avoid unexpected failures. Therefore, you reduce closures of the lane, reduce delays, improve safety, and increase track availability. So when we have here, these are all the innovation from Work Package 1, well, not all, but 3 of them, and we calculated all the investment costs and all the subsequent running costs necessary to have these technologies, and we sort of say, okay, the net present value for each of these technology will be higher than 0, will be positive, if at least there's a saving of so much every year. Right. This was based on the Romanian lines, so that's with Romanian data. And you can see, again, so the most expensive one here is the ABA system, but that's also because it has a very high level of precision in detecting track problems, which, if the information is used properly and frequently, it can lead to much better planning and much better operations of the tracks. But there are, of course, other innovations, for instance, the smartphone, which is much cheaper, may not be as detailed as the ABA, but could also detect some other issues, for example, related to comfort in the vibration in the tracks, and be really cheap as you probably wouldn't even have to do a CBA to realize that if you equip a train with that technology and you're able to use information, it'll probably improve your current situation. So summarizing, what we've seen is that we can have technologies that not only can save money, right? They do cost money to begin with, but at least in the NeTIRail project, the idea has been to do things that can save you money, especially in the long run, and improve quality at the same time. We also did some work where we looked at this relationship between the cost and quality. You may argue, if you want to improve your quality, you have to invest. Well, not necessarily. Sometimes, especially when we look at innovation and technologies, you can look at improving quality at the same time that you reduce cost. But of course, this is more over a longer period of time, not just in the short term. So NeTIRail has been able to provide some low or even no upfront investment cost innovations and technologies that unlock possibilities like the monitoring techniques, helping hopefully to switch to more preventative approach in railway systems and benefiting all, so infrastructure managers, operators, and also end users at the same time. So that's one part of the analysis. I'm going to move on to the next one. So shall we hold on for questions later?
Yes.
Yeah. Okay. This is all the list of deliverables. If you want to check any of them, this presentation is mainly based on D1.4 and D1.8.